Thank you so much for this great intro. So I'm very happy to be here today with all of you in this great celebration of OWASP 20th anniversary. I guess OWASP has one more year before they can drink in the US, but you are more than welcome to visit us all over the world. So let's start talking about the big challenges from the past and unfortunately also the present that's trying to hold us back, and how we need to make sure that we're moving forward to the future. So to be honest, we are in the future already. We live in the future at the moment. How do I know? I know because our previous generations told us. For example, this is what was thought in the 1960s how a car would look like. As you can see, it is a self-driving car. I guess that we're definitely in the future in that term. Here is another way in the 1930s, how schools were imagined. I guess we are almost there where we're using more podcasts. And I think this is just a step from the current, let's call it studying from home or school from home that we have in this era. And the last one, my favorite probably, that proves that we're in the future, again, from the 1930s. I guess this is the first people who thought about smartphones, FaceTime, so we're definitely in the future. So why do I care about the past and the future, or how the future looks from the past, or the other way around so much? So as introduced, I'm the head of security research in Checkmarx. I'm a security researcher, used to be a developer until I found out that I'm better at breaking things than building them. I lead several OWASP projects, including the API security one that is moving towards a new edition in the next year. And also I'm the founder of the AppSec Village in DEF CON. But to be honest, I have one superpower, and the superpower that is fueled mainly by my research in Checkmarx is the ability to see mistakes and to look at the mistakes in the eyes of a researcher, to see them, how they look like in real life in the industry, trying to think what changed from past mistakes to current mistakes, and definitely thinking about how we're seeing the trends move forward and what we can do to avoid these mistakes and problems in the future. So let's take a very quick glimpse on Memory Boulevard, how we got from around 2000, from the non-virtualized hardware to where we are today in the very modern cloud-native era. So after having actual hardware in actual rooms with actual shelves from iron usually, and making sure that we have all the fire extinguishers and air conditions fixed to the lowest temperature, we moved forward to the era of virtualization. Virtualization did not really cut all the cables. We moved later to infrastructure as a service. I think that Amazon is probably the best example for that in this era. Obviously, others followed later. Then around 2009, we saw the wake of platforms as a service, followed by open source infrastructure as a service like OpenStack. Later, we saw open source platforms as a service. And then just to make sure that we managed to bounce into the future, we saw containers right in time for all the microservices that we needed. And this is obviously a very, very big portion of how cloud native architecture is built this day. I think there is another way to look at this history. This is my way of looking at it. And this is the buzzword of the year along the years. I think that buzzwords move business more than technology these days. So let's see the buzzwords of the year. So around 2005, application security was the buzzword of the year. around the time that Checkmarks was founded. And it's not a mistake. I think that every buzzword brings a lot of vendors around it. Around 2010, open source security became the buzzword of the year. Around 2015, container security. Around the same time, also serverless security. 2019 brought the API security to become a very, very common buzzword, and this was one of the reasons that the OWASP API security top 10 was founded. And then the last component at the moment is infrastructure as code, or some people say everything as code basically, and the security around it. So every buzzword along the years brought many, many vendors with a similar challenge. All of them wanted to give a very good solution for the security they are handling, but they had to choose. They had to choose if they want to give an early solution or an actionable solution. And let me explain what I mean here. The shift left approach, which is also known as the developer first approach, this is something that a lot of us is automatically moved towards these days. And there are very, very good reasons for that. We see that the results are shown early. Early means easier, easier means cheaper to fix. And also it's better for security education. We know a developer did something, very early finds out there is an error or a mistake, and they can still fix it and learn from the experience, which is great. But not everything is great with early, because there are very high percentages of false positives. Everyone who ran a SaaS solution knows that. And also the results are a bit general, and I will show in a second what I mean about that. The other option is to go for actionable results. This is kind of the shift right approach, when you have results that arrive much later in the process, sometimes in runtime, sometimes when it's too late. Obviously, not a very good solution. The good thing is that they have a very low or relatively low percentage of false positives, and the results are specific and actionable. This is the first challenge. This is the first challenge of every vendor, and obviously the first challenge of every company that uses a security product. They need to choose if they want something early or actionable. And here's an example of how early versus actionable looks like in real life. Let's say that the code was written, it did not run yet, not even all the code, just part of the code. It was written, tested, and got this result. The result says the open source package in your application's manifest is found vulnerable to CVE something something. This is not a real CVE, I hope anyway. I have a lot of questions after this message. Is my app really exploitable? Do I really use that in an exploitable way? How do I prioritize the fix of it? Maybe it's okay, maybe it's not. Should I wait for a patch? Should I fix it myself? Maybe I should use something else. These are many, many questions that I get, but I do get the result early. Now, on the other side of this spectrum, there is the actionable result. For example, I'm running a solution. It's not in the code anymore. It's in runtime, running solution tested, and I actually get the following message. Your method, let's say important stuff, is getting tainted data from the exploitable open source vulnerability, the same one. Obviously, I have much more information here. It is definitely a problem. I know that. I see that it is getting tainted data. I should definitely patch or fix or use something else, but maybe it's months since I actually wrote this code. It's the first build we're doing, the first time we're running it, it's the first detection. Back to the drawing board. What does that mean for me? It might be a huge waste of time and obviously money. So this is a very, very clear challenge. This is a polling question that I give to a lot of people I meet. And what kind of results do you prefer? I'll be happy if some of you will write your opinions in the Slack channel so we can see it later. But I'm going to tell you the results that I usually see. So When I ask people what kind of results do you prefer, early and general, late and specific, or maybe not sure, usually most of the answers are around A and C. A is because we learned that being there very, very early in the process of shifting left is the right thing to do. I tend to agree. And not sure, also it's a good answer because many people are not really sure. There are pros and cons for each of them. I can tell you that for big organizations where they have dedicated professional personnel, most of them prefer to start to have results early and general, just because they have the firepower to handle that, the triage and false positives, etc. Other organizations that are sometimes smaller or less professional around security or have less manpower around this type of task usually tend to choose more late and specific. No surprise here. So that was the first challenge. The second challenge I want to talk about is the fragmentation in the market. So we saw along the history of the technology how things move. So in the past we had our applications, later we had different services or even microservices, that's fine. But we had a very, very clear solution for that. We had a SaaS solution, or we had some sort of a code scanner that is going to take a look at my code and tell me what's wrong and what should I fix. That was great for the past. What happens now when I add open source? I have a lot of open source components now, and these components need some sort of dedicated tool to check them, obviously. We call that software composition analysis. Also, we have containers. How do I know that my containers are fine? This is somewhat related to open source, but I still need to know that my containers are okay, that I'm using clean containers. Also, there is some sort of orchestration layer that is running everything. Is everything there is okay? I need to check that also. What about my APIs? API can be handled in the code, in API gateways, in the infrastructure, so many places. Is my API secure? And the last building block that we see is the infrastructure that now moves to become an infrastructure as code with tools like Terraform and CloudFormation, etc. We have everything in there. I need to somehow test that as well. So each one of those needs some sort of dedicated tool, really. So we all know the joke of how many engineers you need to replace one light bulb. My variation here is how many vendors does it take to secure a cloud native or a modern architecture these days? This is a real challenge, which brings me to the next polling question. How many security vendors, either commercial or open source solutions, do you need to cover the different components of your cloud native architecture? Again, this is a question that I ask a lot of time when I'm giving lectures or even talking to CISOs or other AppSec professionals in the organizations. I'll give you 10 seconds to think. Okay, so most of the answers are C and D usually. I think more than 50% of the answers are usually around more than 5, or they don't even know or not sure. The lucky ones that somehow manage to aggregate things are around B. And those who say 1 to 2 are very, very few and usually very, very wrong. Maybe not all of them. I don't know. Maybe there is some sort of a magic solution. But this is what we see usually. And this is a real issue. This is a real problem and a real pain. I think that everyone hates to juggle between various tools and different approaches and different solutions for problems that are part of the same issue. The third challenge is known both to parents and children. We call it legalization. I think that every parent knows that the hardest substance in the universe is a Lego brick. But it doesn't really matter how hard and secure it is. Every child, and to be honest, every malicious attacker also knows that it's not the brick that's important, but the way you build it and the way the other bricks hold it and support it. So here's an example. Here is a brick, application code. This is one of the bricks. I'm going to scan it like in the past, and I see that the sensitive data is written to an S3 bucket. This is the knowledge I have about this brick. Is it okay? Is it not okay? I mean, this is where data is written to these days, right? Into some sort of bucket or storage device. Is it supposed to be there? I guess so. I mean, what's the problem here? No problem that I can see. In a different scan of a different block of the infrastructure, I scan again and I see that an S3 bucket is open to the public. Okay, I don't know if that is an issue. I'm looking at this specific brick. I'm seeing that the bucket is open to the public. That's fine. I mean, some buckets should be open to the public, obviously. For example, if I hold, I don't know, the graphics of the logo of my company, or it can be profile pictures or whatever. Some buckets are open to the public, and that's fine. Where is the glue between them? And the glue between them is some sort of correlation. If I correlate these results, I can see that sensitive data is written to an open S3 bucket. This is obviously a very, very problematic leak of information. Another example. In the first case, we have application code. This is my first brick or my standalone brick, and I see that data is read and written to and from mountain storage. If I look at Kubernetes configuration, I can see that the storage has read and write permissions. I mean, when I look at them separately, it looks fine. To be honest, even if I look at them correlated, it seems fine. But in a very, very similar case, I can see an application code that the data is read from mounted storage, and I see in the Kubernetes configuration that the storage has read and write permissions. So I agree this is not as serious as the data leak we saw in the first example, but if I have the glue between these bricks, the mesh up, the correlation, I can definitely see that there is an unnecessary write permissions in case 2. And this is something I cannot see in the way that we're currently testing and looking at our applications. And this is the third challenge. What we see here is that application security is not only application code security separated from infrastructure as code security, separated from third-party components, etc. We need a holistic approach here. And I'm going to propose a vision here that we're currently playing with. And this is a single repo to rule them all. We know that Git today holds everything, right? All the components we saw before. We want to create some sort of application security testing platform or mashup layer or correlation layer or whatever we want to call it, to scan and to make sure that we see not only the components, but the glue between them. Everything between each and every component should be meshed up to have this correlation in results and understanding of what's happening there. The mashup layer can give me the connection of different things. For example, exploitability of open source vulnerabilities. This is the example we saw in the beginning with the made up CVE. So now I have not only open source and software composition analysis, but I can mesh it with the SAST results and see how it actually affects my code. I can look at overly permissive Docker configuration, for example, when I scan SAST and Docker and I mesh the results. SSRF that affects Kubernetes, for example, Kubernetes Management API. Suddenly, if I scan all of them, I have the scan of code by SAST. I can look at my Kubernetes files. I can look at my API security. If I can mesh them together and correlate them together, I can find that kind of specific complex to detect issues and find them quickly. It's important to say that it's hard to detect, but these are exactly the vulnerabilities that malicious attackers are looking for. They don't really care about how things go behind the scenes. Behind the scenes is our problem. Their problem is to try and just find a weak link, and they usually do. More examples, overly broad permissions or unprotected sensitive resources. If I have access to my infrastructure as code files and also to the code itself, I can make these connections. And the examples go on and on, obviously. And we see that the exploitability of imported container layers vulnerabilities becomes suddenly simpler when we have vision into code and open source and containers. And a lot of things that run in Lambdas are also relevant. We can see serverless vulnerabilities and misconfigurations when we look at the code of the Lambdas and the infrastructure as code configurations. So basically, we see everything. We have not only the code, we suddenly have the context. And the code is something that we always had when we shift left, but the context was always missing and only appeared when we shifted right. So a unified AST mashup solves these challenges because we have a single polymorphic engine that points to a repo with all application codes and infrastructure as code. We see different engines running behind the scenes and connecting everything. The first challenge we talked about, the stubborn trade-off of early and actionable, it disappears. All is code. So the mashup is the glue that combines all results and supports both requirements of shift left and actionable results. The annoying market fragmentation we talked about, it's not needed anymore because the mashup aggregates or even unifies the results to give us better context and also new results that we never had before. And this vision shows also kind of a bonus, I think, when we look at stakeholders and the time it takes. So if in the past we could look at application code after it was coded and built by developers, then we could run some sort of vulnerability scan. Then maybe the DevOps would need to run some sort of container security protection or testing to check the containers. And then under production, we need IT to make sure that the network is okay. Again, it's multiple products, multiple processes, multiple stakeholders, and we're missing the correlated results that we saw earlier. In the future, I'm hoping that not in the next 20 years, but less than that, we're going to see a one click that starts everything and all the scans and testing done in the same place. So we can see as soon as the code is built or started to be built by developers, we can look at the application code for vulnerability scan by SAST or SCA, look at the containers, look at the infrastructure as code, and have all the information in a single product, in a single process, by a single stakeholder, and basically have here the synergy that we like so much to talk about. So just to summarize, I think that we definitely see a brighter future. And I think that our summary needs to be, what do developers and security staff want? And we know that we want seamless integration because we don't want to handle so many vendors. We want very intuitive point and go, point at a single repo and go. We want early results, shift left. We want actionable results, shift right. And to be honest, we want to eat the cake and have it too, especially if it's an OWASP 20th anniversary cake. So thank you so much. And I hope to see you and your questions in the Slack channel that is currently on the screen. Thank you.